Today, we venture into the abyss of space with us as we unveil the tales of near misses and harrowing escapes that are rarely told. From the silent void above Earth, these stories of survival and ingenuity emerge, showcasing the razor's edge upon which the fate of astronauts and cosmonauts has often hung. Join us on a journey through time, where each mission reveals the relentless spirit and quick-witted responses that have turned potential catastrophes into triumphs of human will and technological prowess, instilling in us a sense of hope and optimism for the future of space exploration. Number 10. In the annals of space exploration, certain episodes stand out not just for their scientific achievements but for the sheer human grit and resilience they showcase. One such episode is the Soyuz 5 ordeal, a gripping tale of survival against the odds in the hostile expanse of space. Launched on January 15, 1969, Soyuz 5 was part of the Soviet Union's audacious space program, a daring endeavor aimed at pushing the boundaries of human spaceflight. Commanded by Boris Volynov, the mission was a ballet of complex maneuvers, including a rendezvous with Soyuz 4. However, the mission took an unexpected and perilous turn during re-entry, setting the stage for a dramatic saga of survival. As Soyuz 5 began its descent back to Earth, a critical malfunction struck. The service module failed to separate from the re-entry capsule, causing the spacecraft to enter the atmosphere nose first. This abnormal orientation subjected the capsule to intense thermal stress and aerodynamic forces, far beyond the design limits. The investigation into this incident centered on the spacecraft's design vulnerabilities and the sequence of mechanical failures. Meanwhile, Volynov faced the immediate challenge of manually rectifying the capsule's orientation to prevent a catastrophic end. The Soyuz 5 ordeal stands as a testament to human resilience and technical prowess in the face of unforeseen disasters. Boris Volynov calm under pressure and his ability to execute a manual re-entry maneuver not only saved his life but also provided invaluable lessons for future space missions, enlightening us about the importance of preparedness and adaptability in space exploration. Number 9. In the shadow of the monumental Apollo 11 moon landing, the Apollo 12 mission embarked on its journey to the lunar surface, only to encounter an electrifying predicament. Moments after liftoff, the spacecraft was struck by lightning, not once but twice, thrusting it into a vortex of technical chaos. Apollo 12, the sixth crewed mission in the United States Apollo program, lifted off on November 14, 1969, from Kennedy Space Center. Commanded by Charles Pete Conrad, it aimed to perform extensive lunar surface exploration. However, just 36 seconds post-launch, the mission nearly ended in disaster. A sudden storm over the launch site led to 2 lightning strikes that crippled the spacecraft's electrical systems and cast doubt on the mission's continuation. The lightning strikes caused a complete power failure and erased critical flight data, putting the crew in a precarious situation. The mission control and astronauts, led by the composed guidance of Flight Controller John Aaron, scrambled to diagnose and rectify the issue. Aaron's call to try SCE2AUX, a relatively obscure switch setting, allowed the crew to restore the telemetry and regain control of the spacecraft. The investigation that followed revolved around understanding the lightning's effects on the spacecraft's systems and the atmospheric conditions contributing to such a rare event. The Apollo 12 lightning strike incident is a riveting chronicle of crisis management and technical expertise in an era when space travel was in its nascent stages. It underscores the unpredictable nature of space missions and the critical importance of teamwork, knowledge, and rapid decision-making. Number 8. The Space Shuttle Atlantis STS-27 mission in 1988 is a less sung, yet harrowing narrative of spaceflight, marked by a nearly catastrophic encounter with damage that could have rewritten history. Launched on December 2, 1988, STS-27 was a classified military mission for the United States Department of Defense, carried out by the Space Shuttle Atlantis. Shortly after liftoff, the shuttle's thermal protection system sustained significant damage when it was hit by debris. This incident, initially undetected, set the stage for a tense journey that tested the mettle of both the astronauts aboard and the engineers on the ground. The damage occurred when a piece of insulation broke off from the right solid rocket booster and struck the shuttle's thermal tiles. The severity of the damage was not fully appreciated until Atlantis re-entered Earth's atmosphere, when the true extent of the risk became glaringly evident. The incident sparked extensive investigations, leading to a re-evaluation of shuttle inspection protocols and damage assessment procedures. Engineers and mission specialists meticulously reviewed flight data, analyzed heat shield integrity, and developed contingency plans for future missions to prevent such oversight. STS-27's brush with disaster serves as a stark reminder of the innate dangers of space travel and the crucial need for meticulous inspection and preparedness. The mission exemplified the thin line between routine operation and calamity, reinforcing the importance of vigilance in space mission protocols. Number 7. The Gemini 8 mission, an audacious test of space endurance and docking procedures, veered into a near-disastrous episode that threatened to end the lives of its crew. Launched on March 16, 1966, Gemini 8 aimed to achieve the first docking between two spacecraft in orbit, a crucial milestone for future lunar missions. Commanded by Neil Armstrong and piloted by David Scott, the mission was on course to make history. However, shortly after docking with the Agena target vehicle, the combined spacecraft began spinning uncontrollably, setting the stage for a critical test of astronautical resolve. The investigation into the Gemini 8 incident revealed that a stuck thruster on the Gemini spacecraft was responsible for the uncontrollable spin. The malfunction forced Armstrong and Scott to undock from the Agena, which only accelerated the spin rate. Faced with increasing G-forces and the real risk of blackout or death, Armstrong made the split-second decision to use the Re-Entry Control System (RCS) thrusters to stabilize the spacecraft, a move that was both risky and innovative. The Gemini 8 mission remains a seminal chapter in space history, highlighting not only the perils of space exploration but also the incredible presence of mind and adeptness of its astronauts. This incident provided valuable lessons in spacecraft design, emergency preparedness, and the unpredictable nature of space travel. Number 6. The Soyuz TMA-11 mission 2008 stands as a reminder of the perils lurking in the seemingly routine journey back to Earth from space. This mission turned into a gripping survival story when a re-entry mishap pushed the limits of human endurance, highlighting the unpredictable nature of spaceflight and the resilience required to face its challenges. Launched on October 10, 2007, Soyuz TMA-11 carried an international crew from the International Space Station, ISS, back to Earth. The mission was expected to conclude as many before it had, with a controlled descent and landing. However, an anomaly during the re-entry phase led to a harrowing experience for the crew members, testing their survival skills and the robustness of the Soyuz design. The incident occurred when the Soyuz spacecraft's service module failed to separate properly from the descent module, causing the craft to enter the Earth's atmosphere at an incorrect angle. This resulted in a ballistic re-entry, a steeper and faster descent that subjected the crew to extreme G-forces. The investigation focused on the pyrotechnic bolts designed to separate the modules, revealing a flaw in the separation mechanism. This inquiry led to an understanding of the technical failures and the initiation of measures to prevent future occurrences. The Soyuz TMA-11 re-entry incident underscores the inherent risks of space travel and the critical importance of robust system design and emergency preparedness. Despite the severe conditions, the crew's survival attested to the effectiveness of their training and the Soyuz spacecraft's safety features. Number 5. The Soyuz 18A mission, intended to be a routine space expedition in 1975, quickly escalated into a dire survival scenario following an aborted launch. This incident vividly illustrates the fine line between routine operation and emergency in space travel, highlighting the unpredictable nature of space missions and the critical importance of rapid response mechanisms. On April 5, 1975, the Soyuz 18A mission faced an unexpected crisis shortly after liftoff from the Baikonur Cosmodrome. The mission was planned to transport 2 cosmonauts to the Soviet space station Salyut 4. However, a malfunction during the second stage separation triggered an emergency abort, catapulting the spacecraft and its occupants into a perilous and uncharted trajectory. The investigation into the Soyuz 18A incident revealed a premature separation of the second and third stages of the rocket, caused by a mechanical failure in the separation mechanism. This malfunction led to an emergency abort sequence, launching the spacecraft's descent module into a higher-than-planned altitude and subjecting the crew to extreme G-forces during the ballistic re-entry. The inquiry into the mishap focused on mechanical flaws and procedural oversights, prompting a review of the Soyuz program's safety protocols and design specifications. The aborted launch of Soyuz 18A vividly reminds us of the risks inherent in space travel and the importance of effective emergency response systems. Despite the terrifying ascent and subsequent high-G re-entry, the mission underscored the robustness of the Soyuz emergency procedures and the resilience of its crew. Number 4. The Soyuz T-10-1 mission, etched in space history for its dramatic escape from disaster, is a tale of quick action and miraculous survival. In 1983, a catastrophic fire on the launch pad threatened the lives of the crew mere seconds before liftoff, highlighting the ever-present dangers of space travel and the importance of emergency preparedness. On September 26, 1983, the Soyuz T-10-1 mission was set to launch from the Baikonur Cosmodrome, carrying 2 cosmonauts to the Salyut 7 space station. However, during the final countdown, a fuel valve failure led to a massive fire engulfing the rocket, setting the stage for one of the most dramatic rescue operations in the history of space exploration. The investigation into the incident pinpointed a faulty fuel valve as the culprit, which allowed highly flammable rocket fuel to leak and ignite on the launch pad. The Launch Escape System, LES, was activated just 2 seconds before the fire reached the spacecraft, propelling the crew capsule to safety away from the inferno. This event prompted a thorough review of launch procedures, fuel system designs, and the LES's efficacy under actual emergency conditions. The Soyuz T-10-1 incident serves as a potent reminder of the volatile nature of space missions and the paramount importance of safety mechanisms like the Launch Escape System. The swift and successful activation of the LES in the face of imminent danger not only saved the lives of the crew but also marked a significant moment in space safety protocol evolution. Number 3. Apollo 13's mission statement, "Houston, we've had a problem," became an iconic symbol of space travel's precarious nature and the extraordinary human ingenuity that arises in the face of adversity. This harrowing odyssey of survival, teamwork, and technical brilliance showcases the resilience required to turn a potential space tragedy into a triumph of problem-solving. Launched on April 11, 1970, Apollo 13 was the 7th staffed mission in the American Apollo space program and the 3rd projected to land on the Moon. But just 2 days into the mission, an oxygen tank exploded, crippling the spacecraft and plunging the crew into a desperate fight for survival. This moment transformed what was a routine lunar mission into a critical test of human resolve and technological ingenuity. The investigation into the Apollo 13 incident focused on the explosion of an oxygen tank in the service module, caused by an electrical fault. This catastrophic event led to a loss of electrical power and life-supporting resources. The crew, along with mission control, had to quickly devise and implement innovative solutions to provide enough air, water, and power to return to Earth safely. They repurposed the lunar module as a lifeboat and executed critical course corrections using manual guidance. Apollo 13 remains one of the most compelling narratives in the history of space exploration. It epitomizes the precarious balance between risk and innovation that defines this daring human endeavor. The crew's successful return against overwhelming odds not only marked a monumental achievement in spaceflight history but also provided invaluable lessons in spacecraft design, crisis management, and the indomitable human spirit. Number 2. STS-51F, part of the Space Shuttle program, embarked on a mission that would test the limits of space engineering and human adaptability. This mission, involving the Spacelab 2 payload, was marred by an in-flight anomaly that necessitated a rare and dramatic abort to orbit auto maneuver, turning it into a tale of technical resilience and quick decision-making. Launched on July 29, 1985, with the Space Shuttle Challenger, STS-51F aimed to conduct extensive scientific research using the Spacelab 2 laboratory. However, shortly after liftoff, one of the shuttle's main engines failed, threatening the mission's objectives and the crew's safety. This incident became a critical case study in space mission anomalies. The investigation into the STS-51F incident revealed that the engine failure was due to a sensor malfunction rather than an actual engine defect. This led to the activation of the auto, a contingency procedure that modified the shuttle's trajectory to a lower than planned but stable orbit, allowing the mission to continue under adjusted parameters. The situation prompted a thorough analysis of sensor systems and engine safety protocols, leading to enhancements in shuttle diagnostic and response capabilities. STS-51F's successful auto maneuver and continuation of its scientific mission underscored the importance of robust contingency planning and the effectiveness of the Space Shuttle's design in accommodating unforeseen challenges. Number 1. The Mir Space Station, a symbol of human endurance and international cooperation in space, faced one of its most critical challenges in 1997. A collision that threatened the lives of its crew and the very existence of the station. On June 25, 1997, during a resupply mission, the unmanned cargo ship Progress M34 collided with the Mir space station, damaging its Spectre module and causing a rapid depressurization. This event put the station's crew in immediate danger and compromised the structural integrity of Mir, raising questions about the station's future and the safety protocols in space missions. The investigation into the collision centered on the manual docking procedure being performed by the station's crew, which led to the catastrophic miscalculation and impact. It was determined that the collision was due to a series of navigational errors and a lack of situational awareness. In response, measures were implemented to improve training for docking procedures, enhance collision avoidance systems, and refine communication protocols between space vehicles and control centers. The Mir space station collision serves as a poignant reminder of the complexities and inherent risks of space travel. It underscores the importance of rigorous training, precise navigation, and robust engineering to safeguard against the unforgiving environment of space. In the vast expanse of space, each of these narratives, from the Soyuz malfunctions to the daring escapes of Apollo and the Space Shuttle missions, embodies the essence of human exploration. The unyielding quest to push beyond known limits, even in the face of daunting challenges. As we've traveled through these remarkable incidents of space history, we've seen not just the perils that lurk in the cosmos but the courage, innovation, and teamwork that define our journey to the stars. These tales, etched in the annals of space exploration, continue to inspire and remind us of the incredible journey humanity embarks upon as we reach for the heavens. Please like, share, and subscribe to the Phantasmal Eternity channel. Until next time.